Attorney Dusty Horwitt has used his experience in journalism, law, and politics to conduct investigative research and advocacy on oil and gas drilling, hydraulic fracturing, and metal mining. He's helped protect the state of New York from unsafe drilling and the Grand Canyon and Colorado River from uranium mining. Dusty's testified before the New York City Council and government panels in Ohio, Pennsylvania, and Virginia, been quoted or cited in media outlets including New York Times, Wall Street Journal, and Marketplace on NPR, and authored a chapter on hydraulic fracturing chemical disclosure in a 2017 textbook published by Elsevier. He's worked at Earthworks, Environmental Working Group, Partnership for Policy Integrity as analyst and senior counsel, a reporter at the Chicago City News Bureau, and as a congressional staff member. Currently, he consults on oil and gas projects for PSR. Dusty will speak about legal issues regarding disclosure of fracking chemicals, how laws leave us at risk, and how we can change this. If you have a question, use the Q&A button and mention Dusty during his presentation. And now, Dusty Horwitt.
I first got involved in research and advocacy around protecting people from the impacts of oil and natural gas drilling and fracking chemicals in the mid-2000s. I was working at a nonprofit in Washington, D.C. called Environmental Working Group when we received a visit from a Colorado-based scientist named Theo Colborn. I had never met Theo, and I don't think I had heard of her. We had just finished a major report at Environmental Working Group showing a large increase in oil and natural gas drilling in the Western United States that was threatening public lands, scarring wildlife habitat. Separately, we had been doing research on the effects of chemicals used in consumer products, like PFOA, that was a major ingredient in Teflon. Theo told us that these two avenues of research were connected. She had compiled a list of chemicals used in natural gas drilling, and she found that a number of these chemicals had very toxic health effects. And she urged us to join with her and her organization, the Endocrine Disruption Exchange, to help shine a light on the use of these chemicals and to protect people from their effects. Here's a picture of me and Theo and our pilot at the airport in Rifle, Colorado in 2007, just before we went on a flight over the natural gas field near Rifle. Theo has been an inspiration to me and many, many other people in the environmental movement, and it was her spreadsheet of natural gas chemicals that is probably the most influential single piece of research in motivating people to get involved to reduce fracking and its impacts on people in the United States and around the world. I want to thank Physicians for Social Responsibility for putting this symposium together. As Elizabeth said in her introduction, I'm going to talk about the rules and laws at the state and federal level regarding the use and disclosure of chemicals in oil and natural gas drilling and hydraulic fracturing. To give a sense of why these laws are so important, I want to read a section from a recent report that was the outcome of a criminal grand jury investigation conducted by the Attorney General of Pennsylvania, released earlier this year. The Attorney General's office interviewed more than 70 families that had reported impacts from natural gas drilling, which has grown tremendously in Pennsylvania over the past 15 years. And they wrote the following: many of those living in close proximity to a well began to become chronically and inexplicably sick. Pets died. Farm animals that lived outside started miscarrying or giving birth to deformed offspring. But the worst was the children, who were most susceptible to the effects. Families went to their doctors for answers, but the doctors didn't know what to do. The unconventional oil and gas companies would not even identify the chemicals they were using so that they could be studied. The companies said the compounds were trade secrets and proprietary information. The absence of information created roadblocks to effective medical treatment. One family was told that doctors would discuss their hypotheses, but only if the information never left the room. So a number of families, not just in Pennsylvania, but in other places where there's oil and gas drilling and fracking, have experienced impacts like this. And so it's very important that we know what chemicals are being used and we know how to keep people safe from them. I want to walk through the drilling and fracking process to give attendees a sense of how these chemicals are used and where they could be problematic. After a well pad is cleared, the first major step in the drilling and fracking process is drilling the well. So the diagram I have here shows the surface of the earth where we live up at the top, and that's represented by those horizontal green lines. And what the companies do is they first insert some conductor pipe into the earth to prevent the earth from caving into the well. Then they bore down through the earth, passing through the groundwater, which is typically close to the surface in the first several hundred feet. And after they have an empty hole in the earth, they insert steel pipe called casing. This first leg of the casing is called the surface casing. Then they inject cement down the middle of that surface casing. It hits the bottom of the well and fills up alongside that casing, cementing it into place, and in theory at least, forming an impenetrable barrier between the groundwater and the well so that water can't get in and so that any contaminants in the well cannot get out into the groundwater to contaminate it. The big risk in the drilling stage of the process is if chemicals are being used when that drill bore passes through the groundwater. If they are, there's a high likelihood that the groundwater is going to be contaminated. And there are toxic chemicals used in the drilling process. Chemicals are typically used to help keep the drill bit cool, and they're also used to help lift the rock cuttings from underground up to the surface to facilitate drilling. After drilling comes the fracking process. This begins when companies set off mini explosions deep in the well where the oil and gas are located. And that well that is drilled continues to be drilled through successive layers of casing and cement all the way down to usually thousands of feet underground where the oil and gas are located. So the well pipe is in place, it's cemented, then the companies set off mini explosions in the well where they want to produce the oil and gas. Those explosions perforate the pipe, and then they inject into that well at high pressure up to millions of gallons of water mixed with sand and chemicals. You can see in this photo of a well site taken by the nonprofit Frack Tracker Alliance of a well site in Ohio, how much material is required to complete these hydraulic fracturing jobs. You can see all the trucks and tanks. There's a lot of water and sand and chemicals coming into these sites. The chemicals in fracking are used for a variety of purposes. Some are used to prevent the growth of bacteria that could clog up the drilling pipe. Other chemicals are used to reduce friction during the high pressure fracking. And still others are used to create a gel in the water so that the sand can be suspended and travel farther out into the underground fractures that help facilitate oil and gas drilling. So this mixture is injected at high pressure. It exits through those perforations deep underground created by the explosions and fractures the formation. Then the oil and gas companies turn off the pressure in the well. The fluid flow reverses and the fluid comes back up out of the well. It can be millions of gallons of wastewater that is produced from wells over their lifetime. EPA has found in a 2016 report on fracking and drinking water that there are more than 1,600 different chemicals that are associated with fracking fluid or fracking wastewater. Some of these chemicals are man-made, others are found naturally occurring in the underground formations, especially carcinogens like benzene and radium. And EPA concluded in that report, after reviewing all this evidence of the chemicals used in fracking and in the wastewater, quote, health effects associated with chronic oral exposure to these chemicals include carcinogenicity, neurotoxicity, immune system effects, changes in body weight, changes in blood chemistry, liver and kidney toxicity, and reproductive and developmental toxicity. So these chemicals can have very serious health effects. And I think that the fact that EPA was able to find that all these chemicals were used in fracking is in part a testament to that early work that Theo Colburn and her colleagues did in the mid-2000s, and that many of the rest of us have built on over the years. Now, the drilling industry has said often that there's nothing to worry about in fracking because it's conducted so far underground, far deeper than where your underground drinking water is found. And there is some truth to that statement. You can see in this diagram that the fracking is indeed very far underneath the groundwater, which is represented in blue near the surface, and the fracking is deep underground. There are typically thousands of feet of separation between the two. However, there are multiple pathways through which the chemicals found in fracking fluid and in the fracking wastewater can come in contact with the environment and with people. For example, wells can leak and they can lose their integrity. Here's a slide from EPA from its 2016 Drinking Water and Fracking Report that shows 5 different ways that fluids can get out of wells. The circle number 1 there shows a breach in the steel casing and a breach in the cement, allowing fluids to get out into the rock formation and potentially into groundwater. Circle number 2 shows fluids can come up through an uncemented space between the rock wall and the steel casing called an annulus. And there are several other ways that the fluid can migrate out of wells. There's also the wastewater. The wastewater can be produced, as I mentioned, in millions of gallons of volume per well. That has to be disposed of somewhere. It can leak, it can spill. It's typically taken to underground injection disposal wells where it's injected underground, supposedly for permanent disposal. But those injection wells have leaked and they've contaminated groundwater. It can be illegally dumped. It can be used for ice and dust control on roads. And then there can be spills above ground of the chemicals used in drilling and fracking. Here's a photo from a terrible well site fire in Ohio in 2013, where the fire caused a number of tanks of chemicals to rupture and melt, and that caused chemicals to run off this well site into a tributary of the Ohio River that caused a major fish kill. So there are a number of ways that people and the environment can be exposed to these chemicals through groundwater, through surface water, also through the air. Wastewater is often stored in large pits on site at fracking sites, and the chemicals can volatilize from those pits and become airborne. So people are at risk, as the Pennsylvania Attorney General found, and those risks have increased over the last 20 years as oil and gas companies have moved into more populated areas where they have sought to drill in unconventional formations as they've depleted the older conventional formations. So there are a number of reasons that we want to know what chemicals are being used in drilling and fracking. I've displayed 3 of the biggest reasons here. One is we want informed decision making. We want to know whether it makes sense to have drilling and fracking in our communities and under what conditions, if we have control over that, which we should, and which communities in Colorado have recently gained thanks to statewide legislation. Another reason to have disclosure of these chemicals is to identify pollution. This is particularly important in what's called baseline testing. That's where scientists come in before there's any drilling or fracking, and they take a sample of, usually it's water, you might be able to do this for air as well, and find out what kind of chemicals are present before any drilling or fracking begins. Then, after drilling and fracking, you come back and you take subsequent tests. If there's a change in the chemicals in the water, and those chemicals were used in drilling and fracking, that's a pretty good sign that it was drilling or fracking that caused the contamination. If you don't have that baseline sample, though, and you later find pollution after drilling and fracking, it's possible that the pollution had been there all along, and you're just finding it now for the first time. So the baseline testing, which would be enabled by chemical disclosure, is very important. And then finally, it's very important for emergency responders and for health professionals to know what chemicals are being used on site so they can effectively respond to emergencies like that well fire we saw in Ohio, and so they can treat patients like the situations that were experienced in Pennsylvania that the Attorney General documented. There are several key elements of meaningful disclosure that I want to talk about before I get into some of these laws and rules at the state and federal level to see how they measure up. So I've listed 5 of what I think are the key elements of meaningful chemical disclosure in drilling and fracking. One is disclosure of all the chemicals used. So we focused over the years on fracking chemicals, understandably, because there are risks there, but it's also important to disclose the drilling chemicals to the public, as well as any other chemicals that are used in oil and gas extraction. We want to have disclosure prior to drilling and fracking so that we can do some of the things I mentioned. The emergency responders can plan, health professionals can know what people are being exposed to. We want to have disclosure of 3 different identities for each chemical. We want to know the chemical's name, like benzene. We want to know its trade name, if it has one. I'm making one up here, like frac flow could be a trade name. And then we also want to know the CAS number of the chemical. That stands for Chemical Abstracts Service Number. That's a unique numeric identifier assigned to each chemical by the American Chemical Society. And that is the most important identifier for each chemical, because chemicals can have multiple names and trade names, but they can only have one CAS number. And knowing that CAS number enables scientists to find out what the chemical structure is, and it enables them to access and enable citizens to access any health data or environmental data that we have about these chemicals. We also want to know the well location, where the chemicals are being used, and finally, we want this information in a searchable database so that we could search for chemicals across hundreds or thousands of wells to see where they're being used, so that we could search for all the wells drilled in, say, Weld County, Colorado, to see what kind of chemical usage trends are occurring there. So let's get into some of the disclosure. I've put on the screen a slide from a FracFocus disclosure from a well in Weld County, Colorado. Now, since 2010, 29 states, starting with Wyoming, have adopted rules or laws that require the public disclosure of fracking chemicals. Colorado is one of those states. And a number of those states, including Colorado, require this disclosure to be made to a non-governmental organization called FracFocus, run by the Groundwater Protection Council and the Oil and Gas Compact Commission. FracFocus does, in fact, put this information in the searchable database, which is good. Other states like Wyoming and New Mexico require disclosure only to the states, and those disclosures are not in the searchable database. California has its own searchable database. So there's some variety in terms of where these fracking chemical disclosures are made. The FracFocus has disclosure records for more than 20 states. It's the single largest repository for this information, and it contains Colorado's disclosure. So let's dig into this a little bit. So on this disclosure here, You can see the operator's name is Anadarko Petroleum Corporation. They're a major oil producer. This is in Weld County. You can see there's a longitude and latitude for this well. That's very helpful. We know exactly where this is occurring. And down toward the bottom, you see that there were more than 1 million gallons of water, 10 million gallons of water injected into this well. So this is a major fracking job. Here on this next slide, you see some of the chemical disclosure. Now you'll see that there are 3 different chemical names being disclosed here. On the left-hand column, there's trade names for the chemicals. Then toward the middle of the screen, it says ingredients. Those are the chemical names, and their chemical abstract service numbers as well for most of the chemicals. You can see some of one of these chemicals, a friction reducer from Halliburton, it has a not assigned term under the chemical abstract service number. That is a cause for concern because you might not be able to get much information about what's really in that friction reducer. On the next page, we can see more chemical disclosure. One of the chemicals on this page that is cause for concern is in the middle toward the bottom. It says heavy aromatic petroleum naphtha. That is a petroleum distillate, and those chemicals typically contain benzene, which is a carcinogen, as well as its cousins, toluene, ethylbenzene, and xylene, which are neurotoxic. So we want to pay attention to that chemical. You'll see a number of these chemicals under the CAS number field have the word proprietary. That means that these are trade secret CAS numbers. The oil and gas industry has defended the use of trade secrets to hide chemical identities from the public on the grounds that if they made their chemical identities publicly available, their competitors could use that information to produce those chemicals, thereby undercutting the original chemical manufacturers and selling those chemicals to other people in the oil and gas industry for less. However, a panel that advised the US Department of Energy found in 2014 that there's a solution to this problem. And that is requiring oil and gas companies to make public the chemicals that they use in fracking, and I would add drilling, in a random list of chemicals that are detached from their chemical additives. In other words, in fracking and perhaps in drilling, companies typically use chemical additives that are mixtures of more than one chemical. And so the Department of Energy Advisory Panel said, let's require chemical disclosure where we take those individual chemical names out of the chemical additives and just list them in random order. And in that way, the public will be fully informed about what chemicals are being used, and the drilling industry will also have protection against its competitors stealing its chemical formulas. And that's one of the major shortcomings of these state rules. Almost all of these state rules, if not all of them, allow allow oil and gas well operators and owners to withhold from the public the names of or the identities of chemicals that they deem trade secrets. Now, oftentimes, when they do that, they are required to provide what's called a generic name, which is a name that can tell you something about the chemical, but not that much. And you can see that on this page. For example, one of the proprietary chemicals is called fatty amine salt, but that's going to be a pretty general name. There are likely many chemicals that have that name, but are slightly different from each other. So we want to know exactly what chemicals are being used because they can have different health effects and different toxicities. Another shortcoming to these rules, in addition to the fact that they allow chemicals to be withheld from the public as trade secrets, is that they almost all do not require the public disclosure of drilling chemicals. They only require the public disclosure of fracking chemicals. That's a big problem. Ohio is probably the only state, and certainly the only major oil and gas producing state that does require public disclosure of drilling chemicals. Now, displayed here a page that shows one of Ohio's drilling chemical disclosures. You can see they also include the trade name over on the left-hand column, and toward the middle, the ingredients or the chemical names, and then chemical abstract service numbers also in the middle. Unfortunately, Ohio also allows companies to withhold drilling chemicals as trade secrets. You can see a couple of these chemicals have CAS numbers that are listed as trade secrets, and that's cause for concern. On the second page here, if you look in under the column that says ingredients, and you go down several spaces, you'll see one of the ingredients is xylene. Xylene is being injected into this well as a drilling chemical, and this particular disclosure in Ohio is required to be made for the stage of drilling that occurs before the casing and cement are installed in the well. This is the stage that goes right through the groundwater. So it's possible that, according to this record, 8 gallons of xylene were injected into this well when the drilling was passing through the groundwater. And if that xylene got into the groundwater, that's enough xylene to contaminate 800,000 gallons of water to an unsafe level. So these contaminants can be very toxic in small doses. And xylene is not even the most toxic chemical that is used in oil and gas drilling. One other major gap in these laws is that the entities that are typically required to make disclosures to the public are the well operators and the well owners. And the problem there is that they don't know the most information about the chemicals they're using. The entities that really know what chemicals they're using are the chemical manufacturers. And the chemical manufacturers are, as far as we can tell, exempt from these state disclosure rules. So if the chemical manufacturers don't tell the well operators and the well owners what chemicals they're using, the well owners and operators are not going to be able to report to the public what they're using, whether protected by trade secrets or not. They're just not going to know, and that's not going to show up on these disclosure forms. And there's evidence of that, including compiled several years ago by a congressional investigation, and there's evidence from Pennsylvania as well that this happens fairly often. Another law that I'd like to discuss that's very important in the regulation of drilling and fracking chemicals is the Toxic Substances Control Act, which is a federal law enacted in 1976. TSCA, as it's known, is aimed at protecting the public from chemical risks by empowering EPA to collect information about chemicals and to regulate chemicals to prevent health and environmental harm. I didn't know until several years ago that under Section 5 of TSCA, oil and gas chemicals proposed for drilling and fracking are regulated. That's a section that regulates new chemicals proposed for use in the United States or existing chemicals proposed for new uses. So if you're making a new oil and gas chemical in the United States, you have to send it through this EPA review process. So my colleagues and I in 2014 sent a Freedom of Information request to EPA asking for their reviews and regulatory determinations of these new chemicals proposed for drilling and fracking. We've received thousands of pages of documents in response over the years from EPA. And what we found in analyzing records for 127 of these chemicals is that in almost every case, EPA found health concerns with these oil and gas chemicals, neurotoxicity, blood toxicity, developmental toxicity, irritation to skin and lungs, and yet routinely, the agency allowed these chemicals to be used commercially in oil and gas wells with very light regulation. I want to show some of the records here, and we found furthermore that about half of those chemicals, 63 of them, likely went into use in oil and gas wells. So here's a record for a chemical that has the EPA tracking number P090205. This was reviewed by EPA and regulated in 2009. So this second slide shows EPA's health concerns about the chemical. So in the fourth line down, you can see EPA had concern for lung effects. And then in the fifth line, you can see concern for irritation. In the sixth line, there's concern for neurotoxicity. And in the, I think that's the seventh line, there's concern for developmental toxicity and liver effects. And then EPA says moderate concern. According to people who are familiar with this process, moderate concern by EPA is not the same as we would understand the term moderate concern. The way EPA understands it is that the chemical would not kill you instantly. That doesn't mean it's safe. So EPA found all these health concerns about this chemical. Then in this next slide, it says P090205 was dropped from further review, meaning EPA approved it for use in oil and gas wells. And it's out there. EPA prescribed some personal protective gear, apparently for workers who are going to be using this chemical, but neither in this record nor in any of the other records we saw on oil and gas chemicals did EPA call for field testing to see if these chemicals were getting out into the environment or if people were being exposed. And we also never saw EPA call for setbacks, which are distances between drinking water sources or homes or schools where chemicals should not be used. We never saw that in these records. EPA told us they don't have the resources to do the field testing that they ought to be doing to follow up on these chemical reviews. Another big problem with the EPA process is that the Toxic Substances Control Act, like these state laws I discussed, enables chemical manufacturers to declare as trade secrets virtually any piece of information. And that was the case with this particular chemical, P090205. Here's the cover page of the pre-manufacture notice that the manufacturer submitted to start this EPA review process. On the next page here, you can see that the company that made or imported this chemical withheld its own name as a trade secret. On the next slide, you can see it withheld almost all of the chemical identifying information, including the CAS number, which is toward the middle of the screen over on the right-hand side, just adjacent to the bold letters CBI. There's a gap where there should be a CAS number. And then on the next slide, you can see the trade name was withheld as confidential, and there's a generic chemical name here, quaternary ammonium compound. That's not very specific. It's going to be difficult to know exactly what that is. And then the final slide shows that the use toward the upper left portion of the slide was also confidential, and the company included a generic use inhibitor for oil field applications there toward the lower middle of the screen. That's also pretty generic. Can't be really sure what this is used for, but it's out there somewhere. Two other rules worth mentioning are rules under the Occupational Safety and Health Administration and the Emergency Planning and Community Right to Know Act. The Occupational Safety and Health Administration, or OSHA as it's called, requires chemical manufacturers to provide what are called safety data sheets. They used to be called material safety data sheets to accompany the use of their chemicals so that workers can be safe around these chemicals. These safety data sheets can provide valuable information about chemicals used in oil and gas drilling and fracking. However, as with TSCA and the state rules on the chemical disclosure, the OSHA rules also allow chemical manufacturers to withhold chemical identities as confidential, and they often do. Under the Emergency Planning and Community Right to Know Act, oil and gas operators have to make available to emergency responders information about what kind of chemicals are stored on their well sites so that the emergency responders can plan in the event of an emergency. However, here too, the oil and gas operators can withhold chemical identities as confidential, and there are other exemptions that prevent full public disclosure. Over the years, we have made a lot of progress in knowing much more about what chemicals are being used in drilling and fracking. And we've been able to use that information in some cases to protect people from drilling and fracking impacts. However, there is a lot more work to be done. As we saw, there is still an enormous amount of secrecy in the oil and gas industry regarding what chemicals are being used. And as the Pennsylvania Attorney General showed us, people are being harmed by that secrecy, and we need to change that. It's important to educate people at the state level about these shortcomings and to tell them about what they can do to change these laws, to make sure that these laws are revised to include those meaningful disclosure techniques that I discussed. It's also important to educate people at the local level. And now, thanks to changes in Colorado law, local authorities have much more power to regulate oil and gas drilling, and they should be advised about these shortcomings and what to do about it. As Theo Colburn showed us years ago, if we educate our friends, our neighbors, public officials, we can help create a movement for public health that continues to gather momentum years later. And I look forward to working with many of the people at this symposium to make sure we continue Theo's important work.